Hello everyone. In the previous video, we have understood what is Newton-Raphson method. In this video, we will try to code that same method. The updating rule for Newton-Raphson method is xn plus 1 is equals to xn minus f of xn divided by f dash xn, where the value of n starts from 0, 1, 2, 3 and so on. Quickly starting the MATLAB code. The first thing we need is the function f. So we will use the input function to enter a function. Then we need to find the derivative of the function. For that we will use symbolic x, and then we will store the f dash value in g using the inbuilt function diff of f comma x, which will differentiate the function f with respect to x. Defining the tolerance, you can define the tolerance as it is asked in the question. The next step of the function is to find the interval where the intermediate value property holds. For that, using for loop, where I have initialized the loop from 10 with the increment of 1 till 10. You can always change the initial and terminal value of this loop, provided you already know that one root of the given function must exist between that range. Using the printing statement, checking if the intermediate value property holds between I and I plus 1. If this is true, then it will print root of the equation lies in interval I and I plus 1. Then we will break this loop, otherwise the for loop will continue for the next value of I. Now in the next step, we have to take the initial approximation of Newton-Raphson method, and we have discussed in the previous lecture that we will initialize the approximation which is close to 0. Now checking if the function value at I is less than I plus 1 or not. If this is true, then it means the function value at I is closer to 0 than I plus 1. So we will take the value of d as I. Otherwise, we will take value of d as I plus 1, and the condition will end here. Now starting the iterative process, where I have initialized the loop from 1 and it will run till 100. storing the value of a as d minus f of d divided by f dash of d, where we have used the variable g for the derivative function, and to substitute the initial value we use the inbuilt function subs. So this statement will work as our iterative process using the printing statement. To print the iteration number and the corresponding xi value, and if the absolute value of the function at a is less than tolerance, then the stopping criteria is fulfilled and we will break the loop. Otherwise, we will update the value of d as a and continue the for loop for the next value of I. In the end, we will use a printing statement where we will print the root and number of iterations Now use this MATLAB code to find the root of the problems as shown here. I hope you have made an understanding of this simple code. If you still have any doubts regarding this video, please let me know in the comment sections. Keep learning.